Child's talking smack. All right. So here we go. So hopefully you remember this, but if you don't, no big deal. For a triangle to exist, the two smallest sides, A and B, have to be greater. The sum of the two smallest sides have to be greater than the longest sides. Letter C is the longest side of a triangle. And then A and B are the other two sides. There are three types of triangles. It can be an acute triangle, it can be an obtuse triangle, or it could be a right triangle. And I don't remember, like, this is not a lesson on like what triangle is what, but I guess the general rule is something like the sum of the two smaller sides. If they're greater than the longest side, then it's an acute triangle, which means that all angles in the acute triangle are smaller than 90 degrees. And if you sum up the two shorter sides and it's less than, and c squared is greater than the sum of the two shorter sides, then you have an obtuse triangle, meaning you have one angle that is larger than 90 degrees. And then if you have a squared plus b squared equals c squared, you recognize that's Pythagorean theorem. This is a what type of triangle? Right triangle. So what are the three? This is not on that, guys. I guess we can add like a little lesson on delta, identifying what type of triangle it is. Maybe it might be an SAT type of question. I don't know. I haven't looked at to see if that would be a legit question. So yeah, so there it is. We're just going to be talking about triangles that are not right triangles. And why do we use the law of cosines? What is the law of cosines? It's just a way, bless you squared. It's just a way to solve for a side, the segment, the length of a segment of a triangle. So let me draw a triangle, guys. I guess because we're gonna derive it from scratch. So draw one of the sides as a perfect horizontal, like, and then I'm just gonna go and do like, bam, and then, bam. So I'm trying not to draw a right triangle. Let me see if I can draw this segment a little better. So there it is. And I'm going to put a grid. How are you going to put a grid on this? So I don't know. I'm just going to go like that. I'm going to make this the origin. And I'm going to go. So there it is. It is the x-axis. This is a y-axis. Is everyone okay? I'm going to call this vertice. I'm going to call this vertice A. I'm going to call this vertice B. Bless you. I'm going to call this vertice C. Those are all capital letters. Angle A creates little a, opposite of it. See? Opposite of that side, that's little a. Oh, man. I accidentally deleted that side. Bless you. Opposite of angle B is little b. So little b is the distance from vertex A to vertex C. And then opposite of angle C is little c. So segment little c, segment little b, segment little a. Is everyone okay? Okay. I'm going to draw a perpendicular to vertex B, perpendicular to the x-axis here. And I guess you can call that your height, but I'm going to call that my y value, because this coordinate here is just some x, question mark, some y value. I guess we can call it x. Not a big deal. If I call, and I'll slow down. Since I called vertex B x comma y, do you agree that this in red has to be x then? Because I called vertex B x comma y? Okay, perfect. Do you guys see this right triangle here that I'm highlighting? Okay. Yes. I'm going to do SOHCAHTOA for that triangle that I highlighted. And I guess let me go ahead and highlight SOHCAHTOA so you can link the highlighted section to the highlighted SOHCAHTOA. See, I think about how to write notes, guys. And so if I just follow this SOHCAHTOA and I'm just following, so this, with respect to angle A, this is adjacent, and then with respect to angle A, the Y is opposite, and with respect to angle A, the C would be the hypotenuse of that highlighted triangle, right? So I'm going to write sine of angle A is opposite, which is Y, over hypotenuse, which is C. And then cosine of angle A is adjacent, which is X, over hypotenuse, which is C. And you could do tangent, but we don't need it for what we're doing because we're doing law of cosines. Are we okay? Okay. So, maybe actually you probably have already done this in physics. Have you done this in physics? Like pretend I want, like, I don't know, there's a force. Here's my force C, and then I want to find the force A or the resultant vector of A. Does that sound familiar to you guys? All right, fine. That's fine. I want to know what A is, like question mark. Like, how do I find the distance? So I'm going to say find distance. Find distance A. Question mark. I didn't even spell distance right. There we go. So hopefully you guys remember the distance formula. The distance formula is the square root of the change in x squared plus the change in y squared. That change in x is the same thing as saying x2 minus x1, and that delta y or change in y is the same thing as saying y2 minus y1. Does that sound familiar to you guys? Maybe you also saw it like this: d squared equals change in x squared plus change in y squared. That's the same thing, guys. So these are the same. They're just definitions. Same. You can think of this as definition of distance, or you can think of this as Pythagorean theorem. See, that's like a squared plus b squared equals c squared. I'll erase this because I don't want you guys to. But so they're all the same. We're still okay? All right. So let's go back to the question. I know that we just threw a whole bunch of ideas at you guys. So you can see why geometry is important, and you're about to see why algebra is important. So if we don't have geometry or algebra, then it's kind of hard to derive these. I want you to see where these come from. So the question was, what is the distance of A? So I'm going to replace all this just with that. So I'm going to write, bless you squared. I'm going to write A squared equals, I'm going to open up a parenthesis, and this means a change in X, right? So I'm just finding, so what am I, Chavez, what are you doing? I want you guys to make sure that you guys understand. Pretty much what I'm doing, let me see if I can change the highlight of this. Do you guys see this triangle that I'm highlighting in, what do you want to call that color? Reddish. You guys see that highlighted portion? So pretty much what I'm doing is like finding the Pythagorean theorem of that reddish highlight triangle. Does that make sense? Okay, so check it out. I'm going to find, what am I going to find? I'm going to find this distance right here. Oh, look, I have a laser. Let me use my laser. I'm going to find this distance right here. I had to pay extra for that laser. You guys know that, right? Yeah, I had to get a subscription. Yeah, I'm using it right now. So I'm finding that distance right there. All right. So what am I going to do? Well, the distance from the segment from the origin all the way to vertex C, that's just B. And I'm going to subtract X. That X is this X right here. That X is this X right there. So you see, if I subtract that, this guy right here. So do you guys see that if I take this segment here, and if I subtract this little piece, that's going to give me all this? Okay. We do see that, right? Okay. All right, so that's what I'm doing. And I'm going to close it, and I'm putting that squared. Child, why are you putting that squared? Because it's that squared, see? And then plus, open parenthesis. Now I'm going to get the vertical displacement. So this red line right here. Let me use my little laser so you guys can see this guy right here. That distance is just y. That's just what or y minus 0, but that's the same thing as just saying y, right? So I don't need the parenthesis then. I'm just going to say plus y squared. So catch up to here, and is everyone okay with this statement right here with a little asterisk on it? Yes. Okay. So that's a big one. All right, you guys ready? I'm going to substitute. Chop, what are you going to substitute? There's nothing to sub. Well, I'm going to see how it says a y there and it says an x there. Well, how about y right here? If I multiply this by c, whatever you do to one side, do to the other, bam. And then you get an expression. You get y equals c sine a. And if I do the same thing with this one, times c, bam. Then you get another expression. You get x equals c cosine a. C cosine a. Do you guys see that? I know there's too many c's every time I say, do you see that? And I also reference c. So here's what I have now. I'm just replacing it. I'm subbing. So I'm going to write sub. A squared equals, parenthesis, leave that b alone there. B minus, and instead of typing out x, I'm going to type out c cosine a. Close it. Are we okay with that? Put a square on it. Plus, and I guess I'll put a parenthesis here. I guess I'll put the parenthesis back in there. And I'm going to substitute what y is again. Y is c sine a. Close it, put a square on it. So are we okay up to here? All right, now we're getting ready to expand it. So here comes the algebra part. A squared equals, and all I'm doing is expanding, guys. So I'll go ahead and write this. I'll circle it, and I'll write it like, all I'm doing is this. B minus c cosine a times b minus c cosine a, because there's a square on it, see? So I'm just going to go, what's b times b? B squared. And then I'm going to go b times c cosine a minus bc cosine a. But you're going to have two of them. Do you guys see that one right there? So I'm going to write a 2 in the front. Do you guys see where I got that? And then negative c cosine a times negative c cosine a is going to be plus, because negative times a negative is a positive, c squared cosine squared a. Are we okay with that? Okay. Law of exponents. Here's that squared. You're going to put it to both of these. So plus c squared sine squared a. All right, we're doing pretty good, guys. Keep going. Are we okay? Yeah, you can see how all the maths are stacked together, guys. So hopefully we're getting better at our algebra as well. You see these two right here, these two, the last two terms? I'm going to factor out a c squared. So here we go. A squared equals b squared minus 2bc cosine a plus, here's my c squared that I factored out, and I'm going to have cosine squared a plus sine squared a. How do we feel? Do we feel okay? All right. What is, bless you, what is cosine squared a plus sine squared a? That's just 1. Good job. Good job, Juan. I miss Juan. I wonder how he's doing. Okay. No, you're funny. LOL. All right, so here's what I have now, guys. I have b squared minus 2bc cosine a plus c squared, which is actually the law of cosines right there, but they make it, they rewrite it to make it look prettier. So here it is. I'm going to rewrite it. All I'm going to do is I'm going to move the c squared here in the middle, and I'm going to move the 2bc cosine a to the right. Now, because it's all on the right-hand side, the signs do not change. So a squared equals b squared plus c squared minus 2bc cosine of a. And there it is. Put that in a rectangle, and we're going to call that law of cosines. And all it is just a way to find the length of what a is, like just to find the distance or the magnitude of a or b or c. Does that make sense? It doesn't have to look like this, guys. You can always, and don't worry, I'm going to come back because I can see some of you still writing. I could have solved for c. I could have solved for b, and it still would have been the same. So let me change my color. So just observe. See how I have a squared there? And look, notice that it's cosine of a. So if I put little b squared on the outside, b squared equals, then everything changes. B squared equals a squared plus c squared minus 2ac. And then cosine, use context clues. What do you think? What angle do you think I'm going to use? B, cosine of b. That's also law of cosines. It's the same. I just reword it. Now you guys hook me up. Let me use purple. What if I write c squared on the outside? Then hook me up with these letters. No, Yanni, that's a demerit. If I write c squared, then I'm going to write, no. Well, okay, so yeah, c squared equals a squared plus minus 2ab cosine c. There it is. Those are all the same, guys. Cool or not cool? Now, if you don't relax, if you don't know, like Chav, I have no idea what you just did. I would like for you to know what we just did, but if you have no idea what we just did, all you got to do is know how to use the formula. You're going to take an exam at the end of the semester called the APA. That's going to be your semester exam. And you're going to have a formula chart online. You click the little button, and it's going to say Law of Cosines, and you're going to see this. I don't know if you'll see all three of them. You just might see the top line. And as long as you know how to use it, you can find. Okay, when do you use the law of cosines? You got it. They got to give you two segments, and they got to give you the angle in between those segments to use the law of cosines. Chubb, I have no idea what you're talking about. You'll see right now. Go to the next question. I'm gonna write the word not to scale. Not to scale. None of my triangles are to scale. And it says in triangle PMF, M is 127, little p is 15.78, little f is 8.54. Find the measure of the third side M. I should have made my. That's fine. We can still see. Third side M. Okay, draw a triangle. I guess an obtuse triangle. So let me see if I can draw an obtuse triangle. There's my triangle. Here we go. P, M, F. The vertices, I labeled them capital letters. So capital P creates little p. So this is little p, which is 15.78 feet. Capital F creates little f. So this is little f. And that one is 8.54 feet. And then angle M is how many degrees? 127. In order for you to use the law of cosines, you gotta have these two segments, and then these two segments, when they connect, you gotta have that angle. Do you guys see what I'm talking about? So the angle is like quote unquote in the middle. I don't want to say middle, but like see, that's the middle, and they gotta give you that angle. I mean that side length and that side length. Cool or not cool? If they were to give me this angle and these two sides, I can't use law of cosines. I have to find that angle. So it just depends. But we're lucky. We've got everything nice and pretty. And look what they want. They want me to find what side? M. M is that long side there. Perfect. I got everything I need to find that side length M. Use the law of cosines. So all I'm doing is using this right here, guys. So where the a squared is, that's my M. And then where the b, that's your p. And then where the c, that's your f. So I'm just going to write. Let's see. What am I going to write? M squared equals... I said p, so let me write p squared first. P squared plus f squared minus 2pf cosine of angle M. There it is. That's my formula. It's just the law of cosines. All you're doing now is what is known in the industry as plug and chug. For you math majors and pre-med majors and engineering majors, plug and chug just means you're just putting in numbers into whatever the letters are. And it's a very common phrase. Plug and chug. And it's the easiest thing. So the only way you can make a mistake is if you don't know how to use a calculator or if you just don't calculate something correctly. So I'm just plugging and chugging, guys. M squared, I don't know what that is. That's what I'm looking for. Equals, open parenthesis, plug in what P is, 15.78, close it squared, plus, open parenthesis, plug in what F is, 8.54, close it squared, minus 2 times 15.78 times 8.54, close, cosine of 127 degrees. Are we okay? Okay. Take your calculator. Before you do anything, we check that it's in degree mode. Right now, my calculator is not in degree mode. If you have the colored one, it says radian on the top. Push mode and go to radian and then push degree. Enter. Make sure degree is highlighted. If you have the colored one, make sure it says degree in the upper right-hand corner there. Second quit. My calculator is now in degree mode. Bless you. All I'm doing is typing this on the right-hand side. 15.78 squared. So I come back. I go parenthesis. 15.78 close it squared. Plus, what was the other one? 8.54 close it squared. Minus 2, open parenthesis. 15.78 close open. 8.54. Close cosine, and then what was it? Cosine of 127. So I push 127, and I push enter, and so there it is. So that's not my M. That's M squared. So I'm gonna write m squared equals, and I already forgot what I had, 484.1426294. 484 point, and I already forgot, short-term memory. 1426. 1426. Give me the last digits. 94, like that. 142694. 1426294. 1426294. There it is. All right. I don't want m squared. How do I get m by itself? Square root. So whatever I do to one side, you do to the other. Square root, square root. So here we go. I'm going to write m equals, and I'm just going to write what that is. So it's really simple on the calculator. You just go square root, and then you just scroll up, and then push enter. That way you don't have to round too much, and then just push enter again. And there it is, 22.003. 22.003. And then I need units. What are my units? Feet. If you have units, use units. And there it is. That's how you use it. How are we feeling, guys? Okay. All right. Let's do this one. This one's a little different, but not by much. It says in triangle XYZ. So I'm going to write not to scale again. Not to scale. So I'm going to draw a triangle. There's my triangle. I'm going to call this X. I'm going to call this Y. And I'm going to call this Z. So little x, big X creates little x, or angle X creates little x. So here's 3. This is 3 meters. That's little x. And then here's angle Y. So that's going to create little y. So this is little y. That's 7 meters. And then here's angle Z. So angle Z creates this guy. So 9 meters. It says find the largest angle. Okay. Check it out. All right, Calderon, no pressure. Relax, 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 relax. From these angles, X, Y, and Z, which one do you think is the biggest angle and why? Yeah, Z, Y. I know, it's angle Z. Why is angle Z the largest angle? Because of what? Because of the 9. Angle Z created that 9. Angle X created that 3. Angle Y created that 7. So angle Z has to be the biggest. Does that make sense to everyone? Yes. All right. So when I use my law of cosines, because I'm looking for angle Z, I'm going to put Z on the, I guess you want to call this on the outside or the left-hand side. I'm going to put Z on the left-hand side of that equation. Does that make sense? Because, see, this is little a. This is angle A. I'm looking for angle Z, so I need to make sure that angle Z says cosine of Z. So I'm going to come over here and I'm going to write, what am I going to write? I'm going to write 9 squared equals, that's an equal sign, just looks a little weird, equals 3 squared plus 7 squared minus 2 times 3 times 7 cosine of angle Z. Because it says I want to find the measure of the largest angle. The largest angle is Z. Does that make sense to everyone? Yes. Okay, now you're going to have to use your calculator a little differently. Relax. Let's do it slow. So here's step 1. I'll number it. Step 1. Step 2. Tell me what those numbers are. So 9 squared that's 81. What's 3 squared? 9. What's 7 squared? 49. And then 2 times 3 is 6. And 6 times 7? 42. Cosine of angle Z. So can everyone do that? Okay, so catch up. Chav, what are we doing? I want to get angle Z by itself, so that means I need to isolate cosine Z. So let's do that. I guess step 3 first is I'm going to combine these two numbers right here. You see those two? So I'm going to go 81 equals 49 plus 9. That is 58. Here's step 4. I'm going to subtract that 58. Move it to the other side. You can just take your calculator. I'm not trying to insult you. 81 minus 58. I know some of you can just subtract them real quick. There it is, 23. So I'm going to write 23 equals negative 42 cosine Z. So that's the biggest error. Sometimes you guys put that 42 with that 58. No, that 42 is with the cosine. It's a product. Are we still okay? Okay, I want to get rid of that negative 42. And no yawning because you guys are going to put me to sleep. I want to get rid of that negative 42. How do I get rid of it? divide it. Divide by negative 42, divide by negative 42. So there's my step 5 here. So I'm going to write it like this. I'm going to leave it as a fraction. Just put the negative in the front. 23 over 42 equals cosine z. So get up to here. I'll write step 6 over here. Are we still okay? All right. How do I get z by itself? How do I get rid of that cosine? Because it's cosine of z. Perfect. Arc cosine, or you can also say inverse cosine. They're both mean the same thing. So I'm going to go arc cosine, cosine of negative 1 of negative 23 over 42 equals z. I take the calculator, and I'll slow down. I take the calculator, and I'm just going to type that in. I'm going to go second arc cosine. There it is. I'm going to put the little fraction thingy. You don't have to. You can probably just type it in. And I'm going to put a negative. I'm going to put the negative on the front. Negative like that. And then I'm just going to type in the number. 23 over 42. 23 over 42. And then I push enter. And there it is. 123.203 or 204. 3 digits after the decimal always, unless otherwise told. Excuse me. Z equals 123.203 or 204. 123.204. Put a little degree symbol. Do you guys see how we did it? Yes. Okay. We just have one more. Is it pretty relatively easy, guys? Okay, yeah, most people think it is. There's our last one. Bless you. Suppose that the length of the sides in example 2 had been, put a D instead of an S there. S equals 3, Y equals 7, and Z is 11. What would measure of angle Z be in this case? Okay, I guess let's do it again. I guess I'll draw the same thing. 3, 7, 9. Not to scale. X, Y, Z, and 3, 7. This is still 3, that's still 7, but instead of that being a 9, that's an 11. Now we're just going to do the same thing again. Because they want to know what was the measure of angle ZB, right? So I'm going to write 11 squared equals 3 squared plus 7 squared minus 2 times 3 times 7 cosine of z. 11 squared, I believe, is 121. But if you're not sure, just type in 11 squared here. I'm not trying to insult you guys, just letting you guys know that you guys have a calculator. And then 3 squared is still 9. 7 squared is still 49. And then 2 times 3 is 6, and 6 times 7 is 42. Everything is still the same, guys. Still the same deal. 121 equals 49 plus 9. That's going to be 58. I'm going to move the 58 to the other side. Minus 58, minus 58. You can go 121 minus 58, 63. 63 equals negative 42 cosine of angle Z. I'm going to divide both sides by negative 42. So I'm going to write negative 63 over 42 equals cosine of Z. And I'll wait. And then to get the Z by itself, you got to take the inverse of cosine, or arc cosine. But this time, a surprise is going to happen. Yeah. Notice that this time when you type that into the calculator, negative alpha y equals enter. I already forgot my fraction. What was it? 63 over 42. 63 over 42. Look what the calculator tells you this time. Ah, Chav, why did it do that? I did everything right. Because, guys, remember this rule that we talked about in the very beginning? In order for you to have a triangle, the sum of the two smaller sides must be greater than the longest side. Well, that's probably the field trip.
Good morning, teachers and staff. Please pardon this interruption. At this time, we need all transportation use students attending the airport field trip to please report to the auditorium with all of their belongings at this
See?
time. Thank you. Once again, all transportation use students attending today's field trip, please report to the auditorium.
You guys have fun.
At this time. Thank you.
Here, can you guys pass these out really quick? That way you guys cannot have. Well, I think she already got one. But she got one. So look, guys, 7 plus 3 is 10. 10 is not bigger than 11. So that's like so you can't have a triangle. It's not possible. What you have, in case you're wondering, here's what you have. I guess let me write it. Well, I guess it's fine. No, let me write it like this. What you have is this. You have 11 here. And then on this side you have 3. And on this side you have 7. Look, it doesn't close. If this were to be a spindle, it would just fall down. Bam. Do you guys see that? So you don't have a triangle. Not possible. How do we feel? So there's no triangle. So when you get to a problem like this is just a trick question. As soon as you see the two smallest sides, add them up. That adds up to 10. Is 10 bigger than 11? No triangle. You can't have a triangle. So it's not possible. How do we feel, guys? All right, that's it. We're done. Let me give you guys today's activity. If you wanted to know, yesterday 100% of the class finished, so that means you guys will be able to finish pretty quickly. And if you guys have any questions, let me know.